Hello everyone, in this video we're going to look at section 10.1, subsection 3, which is hyperbolas. So a hyperbola is a set of all points xy for which the absolute value of the distance between from the two distinct fixed points called the foci is constant, right? So in other words, this is my 2 points, and the absolute value of the difference of these two distances is the same as the absolute value of, say, the distance from here to here, right? Or say if I had the point here, this distance minus this distance is going to be the same as the difference of all the other distances, right? So hyperbolas look a little bit different because they're like not connected, right? It's not some shape that we're used to. It's like two different sides of a shape. So the line through the two foci intersects a hyperbola at 2 points called the vertices. So again, the vertices are the points that lie on the graph of the hyperbola. The line segment that connects the vertices is called the transverse axis, right? So this right here from vertex to vertex is called the transverse axis. The center lies right in between that. Okay, so we look at the following definitions from the standard equation of a hyperbola. So the standard form of the equation of a hyperbola with center at hk is x minus h squared over a squared minus y minus k over k squared, or y minus k squared over b squared. So the top one is when I have a transverse axis horizontal. So that's like what I have up here. And then over here is where I have the I have a vertical transverse axis. So in other words, it looks like this. Right? Okay, how do you know the difference? So first of all, what's the difference? The standard equation for a hyperbola and ellipse look very similar. The difference is an ellipse has pluses in both cases, and the hyperbola has minuses in both cases. And in the other, for the ellipse, remember it was like the bigger guy ended up being, whether the bigger denominator ended up telling us where, if it was vertical or horizontal. Here, in this case, it ends up being if it's horizontal, then I know that the x has a positive coefficient and the y has a negative. But if it's a vertical guy, then the y has a positive and the x has the negative. So that's how you tell the difference in this case. So the vertices are a units from the center, so that's already listed in this picture right here. The foci are c units from the center, where c is equal to a squared plus b squared. Again, use the Pythagorean theorem to find that. That's how you actually found c in the earlier case too with the ellipse. So that's already labeled there. And then the eccentricity is given by the same ratio as before, so c over a. The one thing to help us draw hyperbolas is to notice that hyperbolas have two asymptotes that intersect at the center. So if I were looking at, say, this first picture, I notice that I have a slant asymptote right here, right? And a slant asymptote right here. And notice that those two slant asymptotes meet right at the middle. Right? And that will always happen with a hyperbola. So the slant asymptotes intersect at the center, and they'll actually help us draw these guys, right? Because it's easier to draw the slant asymptotes and then kind of fill in the curved line once you have those. So each line passes through the corners of a rectangle of dimensions 2a by 2b. Why? Well, remember, this distance from the center to the vertex is a, so if I was going to find the width of this whole rectangle, that would be 2a. And then the distance from the center all the way up to here is what we call b, right? So this whole distance from here to here would be 2b, right? So that's that that's where we get that rectangle of 2a by 2b. And the center of the rectangle is obviously just the center of the hyperbola. And the line segment of length 2b joining hk plus b and hk by k minus b is the conjugate axis. So in other words, this small little axis that goes kind of in the opposite direction of the hyperbola is called the conjugate axis, right? And so the next theorem is just going to tell us what the equations of those asymptotes are, right? Those are slant asymptotes, so they have the equation of a line y equals mx plus b. So here, if I have a horizontal transverse axis, in other words, if it looks like that up there, then these are my lines, right? This is my m, right, my slope, because it goes with x. This is my m of the other one. Notice the slopes are exactly just opposite of each other. That's why it's the exact same line except a minus and a plus. So the a over b is the b over a is the m, and then if I take k plus b over a times h, that will give me the y equals mx plus b part of it. But we typically write it in this form right here. Okay, so that, and again, this is the lines if I have a vertical hyperbola. Right. Okay, so now we look at the question. Fortunately, this one's already in standard form to save us a little bit of time, so we don't have to practice doing the completing the square twice. But now we're going to find the center, foci, slant asymptotes, and eccentricity of the hyperbola x squared over 4 minus y squared over 16 equals to 1. So let's just write it. X squared over 4 minus y squared over 16 is equal to 1. First, we can go ahead and say whether this is a vertical or horizontal. Since the x is the one that has the positive, that means that it is a horizontal transverse axis. So in other words, it looks like the pictures we drew everything for, right? This is what our hyperbola looks like. Okay, so now let's label what everything is. So a in this case is what's underneath the x term squared, so 2, because 2 squared gives us 4. B is what's under the y term, so that would be 4, because that's what we squared to get 16. What else do we need? We also need c, right? C is equal to a squared plus b squared. C squared is equal to a squared plus b squared. So let's find that one. So c squared is equal to a squared plus b squared. So 4 plus 16, which would be equal to 20. So c is equal to, what would it be, 4 times 5, so 2 radical 5. So let's find the center, right? My center, we know is always going to be HK, which, and I probably should have written H and K here as well. Remember, H is what I'm subtracting from X. In this case, it's 0. So that means that, pull this center down here, H is equal to 0 and K is equal to 0, because what am I subtracting from y to get here, and I'm subtracting nothing from y, so k equals to 0. So my center, which is HK, is just 0, 0. So this is centered at the origin. Okay, so now I find the foci. How do I find the foci? Well, let's look at our formula here. The foci are c units from the center, right? And so since our picture looks like this and our center is right here, this distance to our foci is going to be c. So what do? I'm going to take the x values of my center and add or subtract c, right? So in order to find my foci, I take the center, which is HK, and I'm going to subtract c, and I'm going to add c from the x values because I'm shifting left or right, not up and down. And the y values are going to stay the same as the center, right? So here I get 0 plus 2 radical 5, so 2 radical 5, 0, and 0 minus 2 radical 5, so 2 radical 5 minus 2 radical 5. Oops. Okay, and so then we want the vertices. So now how do we find the vertices? Well, that's given by the formula. The vertices are A units from the center, right? So looking here, my vertices, say they're right here. This distance, this distance right here is A. So again, I want to take my, in order to find my vertices, I'm going to take my center and add or subtract A from the X values. Because that's shifting it left or right, and I keep the Y value the same. Right? So A is 2, so this would be 2, 0, and negative 2, 0. So then what else do we need to find? The slant, well, let's find the eccentricity before we find the slant asymptotes. So the eccentricity is going to be given by E equals C over A. So C in this case is 2 radical 5, A is 2, so this is just radical 5. So now we find the slant asymptotes. So to find the slant asymptotes, it's going to be these formulas right here, because this is a horizontal transverse axis, right? So I'm going to y equals to k, which is 0, plus, or, well, I'll just say plus for the first one, plus b, which b is 4, over a, which is 2, x minus 0, because h is 0. And then for the other one, it's y equals minus, 0 for k, minus b, which is 4 over 2, x minus 0. So simplifying this, I just get y equals to 2x and y equals to negative 2x, right? They're always going to be, have the opposite slopes, right? And then the final thing we wanted to do was sketch the graph. And again, sketching the graph, really, we can use all the pieces we have here. So I know it's going to be centered at the origin. I know my center is at 0, 0, like we said. So let's do a different color here. And then my vertices are at 2, 0, and negative 2, 0. So 1, 2, 1, 2. So that's where my vertices are. And then now really the next thing that's helpful is doing the slant asymptote. So to do the line y equals 2x, right, it goes through the center because it has a y, what do you call that, a y-intercept of 0 and a slope of 2. So that would be this point that would look like right here would be on there, and this point down here would be on there. And then for the other line, this point here, this would be the negative 2 one. This point right here. So I'm going to draw the asymptotes here. So that looks like this line right here would be 1. I didn't draw it perfectly, but so that is, we'll keep drawing it a little bit. Y equals, that's the one with a positive slope, so y equals 2x. And then the other one, again, we'll try to sketch it. I don't think that's very good. Okay. close enough, right? And so if I were going to sketch this, right, I know it's got to be on the, it's got to hit my vertex, and it's got to have those asymptotes, so it looks something like that. And once again, it's got to be not hit those asymptotes and hit those vertex. So maybe that's something what my hyperbola looks like, right? So that's how I use those slant asymptotes to help draw it. I got to make sure to hit my vertices and to come close to the slant asymptotes but not touch, right? Whoops, should have labeled this as y equals -2x. All right, that's all I have for hyperbolas. Thank you.